Okay, so what do we know about isosceles triangles? What makes a triangle isosceles? Two sides at least two sides are congruent. What do we know about equilateral triangles? All the sides are equal. So this one is at least two sides are equal. This one, all sides are equal. Okay? Now, I addressed this the other day, but let's just review. The sides of an isosceles triangle, do you see how these are marked congruent by those little dashes? What do we know about the sides? Do you remember from the other day when I wrote that down? The congruent sides are called the legs of the isosceles triangle. And then the non-congruent side here is called the base. Now that's important to note because your isosceles triangle isn't always going to be standing up on its base. I could have an isosceles triangle that goes like this. This is your base. It's not always on the bottom. Okay? I should not see people on phones right now. I'm right in the middle of teaching. You have notes that you should be paying attention to. Okay? This is the time of year where I start getting parent emails and such. Why is my kid not passing? And I look up and I see people on their phones and I can tell you why they're not passing, because they're not paying attention when Mrs. Franken is teaching. Okay? If this stuff was easy for you to learn without a teacher, I wouldn't have a job. Right? Okay. Angles of isosceles triangles. The angle formed by the legs is called the vertex. So this right here would be your vertex. This side is a leg. That side is a leg. This side is the base. That's the vertex. So we have the two remaining angles down here. Does anyone know what they're called? Base angles. Okay? So? Yeah, no? Okay. So, there is a theorem about an isosceles triangle. And the isosceles triangle theorem says if you have an isosceles triangle, if I mark those two isosceles, the base angles are also congruent in addition to the sides. So, in an isosceles triangle, the base angles are congruent. So in other words, if I have an isosceles triangle, let's say I'm marking these two sides congruent, and I say this is 20 degrees up here. Could I find the other two angles? That's super hard to see that it's 20 degrees, isn't it? But it's 20 degrees. So what do I know about all three angles of a triangle? They're 180. If this is 20 degrees, that leaves me 160 degrees to split up between these two angles. Well, if these two angles are congruent, then guess what? I have to cut that in half, which makes this 80 degrees and this 80 degrees. Capiche? Okay. So, find x. Do we have a backside today too? We do. Okay. So, what are my base angles? Name them for me. Angle Q and angle R. So this is also 2x. Now I'm just looking for x. I'm not looking for an angle measure. So what can I do? I can say that 40 plus 2x plus 2x, those are my three angles, equals what? 180. So 40 plus 4x equals 180, what would I do then? Subtract 40. So 4x equals 140. Now what? Divide by 4. And what does x equal? 35. Is that a degree? So it's just x equals 35. Okay. All right, the next one. Do you see the two angles that are marked congruent? Yeah. Right here and right here. That tells me that the side between them is the base. So these two sides are the ones that are congruent. So how can I figure out what x is? If they're congruent, 2x plus 6 is equal to 3x minus 6. I'm going to subtract 2x from both sides. That gives me 6 equals x minus 6. Add 12, and x equals what? 18. Again, not a degree measure.
Where did you get 12?
I don't know. I think I added it in my head already. It's 6 plus 6. My brain was one step ahead, recognizing that 12 was coming up. How's that? Is that better? Yeah. Okay, good. Thanks for catching me there. Okay. All right, you try number 3. Actually, you know what? You try 3 and you try 6. Hold off on 4 and 5 for a minute because they're a little more complicated. But try 3 and 6. Take a minute and try those two. Okay, so I think, what can I label this angle as? So, if we remember from the other day, we had a theorem about right triangles, didn't we? If I have a right triangle, what do I know about the other two angles? They equal 90. So I can say 3x plus 3x equals 90. Save myself a little space. Right? Or I could do 3x plus 90 equals 180. That's the alternative. Okay? Either way, you get 6x equals 90. Divide by 6, and x equals 15. Okay? Doing okay? Good. All right, this one. What angle is this? Is that a base angle or is that the vertex? Vertex. So this is a base angle. So what is this base angle? It's also x. So I have x plus 3x, 1, 2, 3 angles, equals 180. So how many x's do I have? 5x equals 180. Divide by 5, and what have I got? Good job. All right, should we check these guys? All right. I need to find x, right? This angle is 6x plus 6. Is that a base angle or a vertex? Base angle. So can I also say that angle is also 6x plus 6? Okay. So if I'm talking about just this triangle right here, DKT, I could say 6x plus 6, there's one angle, plus 6x plus 6, that's the other angle. What's this angle? Isn't it vertical to this one? So if this is 2x, then this is also going to be 2x. So plus 2x. There's the three angles of that triangle. So I set it equal to 180. Go ahead and solve that. What do you get for x? So. All right, look at the next one. The next one's interesting. Well, if I look, I'm going to cross off the little one for a minute and just focus on this triangle. This is 30 degrees. What's this? 90. Can I figure out that one? What is it? It's not 30. It's 60 degrees, right? Because 30 plus 60 is 90, plus 90 is 180. Now, this has a little marking on it. And there's another angle here that has a little marking. What does that mean? They're congruent. So if I know this is 60, guess what? That is also 60 degrees. What other angle is going to be congruent to that one? Isn't this a base angle? So this is also a base angle. So guess what? That is also 60 degrees. So I can just set 3x equal to 60 degrees. And what does x equal? 20. Not too bad? Okay, let's turn it over. The converse to the isosceles triangle theorem says if two angles of a triangle are congruent, then the triangle is isosceles. How is this different than the other side? The other side said if you know it's isosceles, meaning if you know there's two congruent sides, you can find two congruent angles. This one's saying if you know two congruent angles, you can find two congruent sides because you know it's isosceles. Does that kind of make sense? Okay. Let's see what we've got. So if I know that this is congruent to this, then I can conclude that this is congruent to that. The other one was if I know this, I can conclude that. Okay? All right, properties of equilateral triangles. Let's see what we know about equilateral triangles. If a triangle is equilateral, what does that mean? Boom, boom, boom. Then it also is an did I spell that right? Equiangular? Maybe. So if all the sides are the same, guess what? All the angles are also congruent. If a triangle is equiangular, then it is also an equilateral triangle. So if you know all the angles are the same, then you can conclude that all the sides are the same. And then the converse, or the backwards of that, says if you know all the sides are the same, you can say all the angles are the same. If a triangle is equilateral, then each angle of the triangle measures how much? 60 degrees, because all the angles have to be equal. 180 divided by 3 means each one is 60 degrees. Okay? All right, so let's look at this. Number one, what kind of triangle do we have? Equilateral, which means it's also equiangular. So I could say 6x, 6x, and 6x equals 180. Or, if I remember that one angle has to be 60 degrees in an equilateral triangle, then I could just say 6x equals 60 and x equals 10. Does that make sense? The alternative would say 6x plus 6x plus 6x equals 180, that being your three angles. So 18x equals 180. You still get x equals 10. Either way gets you there. So? Okay. All right. This one. What do I have that's congruent? What is marked congruent? The sides are not marked equal. The angles are marked equal, right? But if all three angles are equal, what do I know about the sides? They are congruent also. So I can set this equal to that since I know that they're going to be congruent. So 6x minus 5 equals 5x. I'm going to subtract 6x. So negative 5 equals negative x. Divide by negative 1. And x equals 5. Not too bad, right? Okay. Let's look at this one. KLM is equilateral. KLM. So this side and this side and this side are congruent. Yes? Now this one kind of involves another theorem also. I'm not super fond of this one, but if you drop this line to the base and you go straight down there making 90 degrees and 90 degrees, that's called an altitude. Okay? And what an altitude does in an equilateral triangle is it makes a congruent angle here and here. So if this is 3x, what is this one? 3x. Also 3x. So I have two angles that are both 3x. Together, they make one of the angles of the equilateral triangle. And what do we know about the angles of the equilateral triangle? They're each 60 degrees, right? Just like we did over here, they're each 60. So if 3x and 3x together equals one of the angles of the equilateral triangle, I can say 3x plus 3x equals 60. That gives me 6x equals 60. Huh? And x equals 10. Okay? That one's not my favorite just because we haven't talked about that, but that's okay. All right, number 4, we got a lot going on. Now I got to check, do we have equilateral or do we have isosceles? Is this one equilateral? Yes. Is this one? Is this one? Yes. I don't really need to know that all those are equilateral. In fact, I really don't even need to know any of this stuff. All I see is this has one dash, that has one dash. What does that tell me about those two sides? They're congruent. So 4x equals 40. Divide by 4. X equals 10 again. This side likes x equals 10, isn't it? Okay. What do I know about this one? Is it equilateral or isosceles? As of right now, it's isosceles. Well, that's kind of tricky because it gives me one of the legs and the base, which are not necessarily congruent. Let's see if we can figure out anything about these two angles. If this is 60 degrees, 180 minus 60 is 120. I know these two are the same, so if I cut them in half, or cut that in half, the 120, I know that they're both 60 also. So what does that tell me if they're all 60? I do have an equilateral triangle, don't I? It's not just isosceles. So I can mark that side congruent also. So can I find x now? How am I going to find x? 3x plus 8 equals 4x minus 4. Subtract 3x from both sides. I get 8 equals x minus 4. Add 4, and 12 is the value of x. So? Okay. All right, so this last one. I have a 60-degree angle. That's the base angle, right? This angle then is the other base angle, so it would also be 60 degrees. Yeah? So I have another 60 degrees in order to get my 180, so this triangle right here is equilateral and equiangular, right? Is this one the same? It says these two are congruent, but then it says this. What does that mean? They're parallel. Oh my gosh, that's really coming back to haunt us? Sure is. So if I look here, what do I know? Well, if I talk about this angle right here and this angle right here, how are those two angles related? Those are same side interior, which means what about them? They equal 180. So, does that help me at all? Well, let's see. If this is that angle 60 degrees? Is this angle 60 degrees? How do I know? Let's see if I can go somewhere else. 60 degrees. Okay. How about these two? Boom and boom. Those are also supplementary, right? These two, if this is my transversal, these two are supplementary because they're also same side interior. Yeah? So 60 plus whatever this is 180. So yes, that is 60 degrees. If that's 60 degrees, that's 60 degrees, that's 60 degrees. We got all sorts of 60 degrees. So what am I going to set 4x equal to? 60 degrees. And x equals 15. So you can get some of those parallel lines things again, because those arrows don't mean those sides are congruent. It means they are parallel. Okay? Well, that was an exciting one. All right, let me pass out your homework. Happy studying.